Hello and welcome back to Factorio. My name is abucnasty, and in today's video we're going to continue on with part 2 of the productivity science build. So the last time, to recap what we've done, we've routed all the different materials that we're going to need on the input. We calculated all the items that we're going to need, so I've appropriately ratioed that for the number of belts that are going to be fed as an input here. And then I've also here designed two different variations of the steel column smelters, and we're going to test both of them out. So we've also covered in the last video going in creating in an assembly machine the electric furnaces in Q2 quality or uncommon. And the things that we're going to cover in this video today is I want to go and cover creating the red circuits that we're going to need as an input. So that's this guy right here. And I'm also going to want to be covering the green circuits that we're going to need. So for the first one, we're going to start with green circuits, and we're going to need 375.7 of this. So let's go ahead and workshop that solution. So to make the numbers really easy here, I've already pre-calculated the ratios of what we're going to need. So we're going to need 375.7, 136.7 per second of iron, and 410.15 per second of copper wire. Easiest way to do that is just look at the amount of output that this can consume here once you have the particular productivity modules that you have, and you've placed those in there. And then what we'll see if you open this up, or just look at, you can even use rate calculator for this, just to have it open all the time. I have the calculator mod installed to make my life easy. So the way that you'd say this is, okay, I know that I'm going to need, in this case, I have 178 items per second that this can create. I'm going to divide it by the other way around. Take the amount that I need as the output, 0.7, see if I can type. I'm going to divide it by what it can currently make, so to give me the ratio. And then I'm just going to multiply it by the end product that I have. So in this case, let's calculate it as 195. So that's going to be 409.73. So that's close enough. The rounding errors kind of come in because this is truncating and rounding this. So we could make this a little bit more exact, but it's good enough. Basically, about 410-ish and 136-ish. So the other thing, and I've got laid out all the components that we're going to need. We're also going to need some decider combinators as well. So I'm going to have those queued up, and I'm going to already have those in my inventory so I can use them when we're ready for them. And let's prepare. I'm going to be using medium electric poles for this to run more wires, and I think we're in a good spot. So now we've got everything set up here. Let's start with just setting this up in the middle. The nice thing about this design is that this is 4 tiles wide. And that's really convenient because that happens to be, and let's go ahead and set this up on the grid pattern. If we have 2 of these next to each other, this actually will fit perfectly in line with this. So the really nice thing about that is I know that I'm going to be needing to make 375.7. So, and an output from one of these stack inserters is going to be 120 per second. So technically we can't actually do this with just 3 of these, right? Because that'd be 360 items per second. So we need 1 more. So we'll probably have to clock this just on how fast it's going to output it, because we just don't need it as much, but this should be fine. And then what I'm thinking then as far as this goes, so we'll have 4 just to exceed this, even though this can do 480, we'll just limit the swing condition. I'm going to have this as an output to just have like just 2 stacks. We don't need to fill the entire train for this. And the really convenient part about this is now we can have easily an output that's like this here on the sides. And we could then also have some more inserters that are over here, here, and here. So now, and the reason that is really convenient about that is because when transferring machine to machine, these can do 120 items per second, but once you're interacting with the belt, they are much more limited. So they can't go quite as fast. So we'll do something like this just to have like something to start with, and we'll kind of design from there. So what I'm thinking that I'm going to do next here is I'm going to go through and let's go add the next module that we're going to need. So we'll grab this same one, press Q to select the same building type. So I'm in the editor here to make this simple. So we're also going to be crafting with our electromagnetic plant, copper wires, in uncommon quality. And so I'm going to then be inserting this as well. So if we know how much we're going to need 410. So then that's again exceeding the capacity of just 3 legendary stack inserters, so we're going to grab 4. All right, so we put some productivity modules in here. What we can do now is I'm going to want a couple other things. So ideally, I'd like to be able to directly insert here, and I'm going to try to get this as far away from here so that I can still fit beacons around. I'm going to want this to be smelting directly into here if we can get away with it. So looking at this just to kind of get an idea of how much we're going to need. So these furnaces, when they're smelting, and I'll include the uncommon ore in here just so that we can showcase it for visualization purposes. I'm going to need inside this build to directly insert this all the time. I'm going to be needing to, let's figure out the math for this. All right, so I did the math and calculated that we're going to need 74.54 per second. So I'm just going to go ahead and I just include these always just to make it easy for me to understand what I'm going to need. So I'm going to have then 2 of these inserting directly in here. And we can grab, again, just for visualization purposes, throw that in there. Perfect. So the next thing that I'm going to want to do is, let's figure out how much we're going to need of these iron plates. So in theory, we could get away with 3 of them. So I've tried placing a couple of these different configurations around this, and I'm just going to spare you with the time that it took me to try this out. I'm basically, the numbers that I'm getting is not going to get us to the 137 that we're going to need for iron. So even like directly inserting it, I just can't fit enough beacons around there. So 118 versus 136 that we need. So let me try to rework this. Because we're already using cargo wagons, I guess what we could do, and this is going to be a complete deviation from this original design, but I'm going to just try putting this right next to it like this. And let's just remove all this extra stuff. This is fine. And let's have another one on the other side. I would be adding 2 more inserters, but I don't think it's so bad if I can just clock it and have them insert at the same time that these happen to insert. So then it should be minimal amount of additional overhead. Plus, I think the nice thing about this is I can just fit this directly under here and here as well. And then what's convenient about that is then I could just, I can limit both of these in the same way. And I could even be more explicit just to make it obvious what's going to go in here by right-clicking the middle mouse button there, applying that by shift right-click and shift left-click. Now what's nice about this design is now I can fit an extra beacon in here, which I couldn't do before with the other design. So, and get an extra one in here. So now I think I should be able to get like 6 beacons around this, like this. Yeah, so that is easily going to hit this number. Now all I got to do is just workshop this so that I have 136.7 divided by 4. So 34.17, that's easy. Like we're already hitting that with just 6 beacons over here. And we probably can do just, let's see. Yeah, we could even do just 5 and be completely fine if we use 4 furnaces. So we might even be able to get away with 3, but we'll see. So okay, this is convenient. So I'll grab some of these just to kind of model the inputs. So let's say that we do something like this, and then up here, and we could even come a little bit more over, and then have this right along there. Because like, I'm thinking of doing here is I'm gonna have a belt that comes in. And we already decided in the previous video that we're gonna be splitting these belts. So there's gonna be, and I've decided that just because like, I knew the amounts of iron and copper that we were going to need, so we're already pre-splitting them down here. Let me copy this, and we'll come back over here for this design portion. So I like to use these constant combinators. I've mentioned this in the past, but I just want to reiterate it. When you're using the editor extensions mod by Rhaegar, you can then use these constant combinators, and I like to use this as kind of like an input that specifies what is going to go into this build. And then what I can do here is I can shift right click and just easily shift left click on this. So that later on, like I can copy this as a blueprint easily, and then this has a really nice marker for what's going in, but then I can also copy the constant combinator and directly apply it to the infinity loader, and that just kind of speeds up my development life cycle. This is pretty good. What I want to do is already kind of rethink about using this belt for the copper that's going to come in. So I'm thinking what I'm going to do there then is I'm going to try to get this here somewhere, and then let's just move this belt over by 1. That's perfectly fine. And that's convenient because then I can just easily just route this up here and over. And we're still going to need copper later to make, for the red circuits, copper cables. So I'm going to let this just flow through here. What I'm going to do next is I'm going to go and let's place as many beacons around here as possible. So I'll just design the one side and then I'll just mirror it and flip it on the other side. So I'll already take this because we know we already designed this here, and we'll move that over there, and then I will copy what we have here and just move it over there just for the purpose of display here. So good, that's a good spot. So conveniently, what I could do is I can't go all the way over, but I can come here. So I can just move this in like this here and get another beacon in. Let's just get this all the way up here as far as possible. And let's see if I can fit one more beacon down here. Okay, so the placement doesn't matter, and this is going to all line up, so this is okay. So what I would like to do then next is I'd like to get then, I'll just keep on stacking beacons around here. And then let's just move this up because I don't need this space anymore. So we can move these beacons in just like this, so keep it all nice and compact. And then what I can do is, let's delete this just so that it's something that I can mirror easily. And then we'll figure out the final ones that we're going to add in a second. I don't really care about this being on the wrong side. I can just flip this afterwards. And then delete this. And delete this. And I actually do care, because that's actually how it's going to be modeled, so I'll just display that. Rotating this, unfortunately, doesn't work anymore in 2.0 to flip the different sides, because these now have logistics groups that they can be named in. So you can no longer press H to rotate and flip this, and it doesn't do anything. Even though the indicator highlights that you're doing something, it doesn't matter. And even if you switch the orientation here, it doesn't change anything on the constant combinator because they're by the ID of the item type. So I can't go and easily model it, so you just have to kind of hope that the user understands it when you make the blueprint. So okay, so we need to make 74.54 per second. Let's see if we're at that point. Yep, we're easily there, but we can easily fit a couple more beacons in here without a problem. So what I could do here is I can move these two in here just to fit them in. We can move this whole thing down. And then I could have this effectively then, I guess if I'm gonna lay this out, I could have one more beacon in here and in here. So that will then easily exceed it so that these machines can stop occasionally. And this is only going to consume per side now 26 ore. So again, that constant of back pressure, we're completely fine there. So looking at this now, all right, we've already got green circuits coming out here. Great. So let's go and have this come in as an output. And what I want to monitor is, I'm assuming that this should stop working at some point because we should be under ratioed. We might not be. Now that we're exceeding this amount, we might be able to actually fully push 427 per second out of here. So that's convenient. It's not quite a full 2 lanes, but it seems like we can pretty easily do this now. Cool. Okay, so we're starting to get iron limited, but that's okay because we know that we're already producing... Oh, no, I need more beacons on that side. So let's figure that out. And I want these ideally to all be the same exact speed. Make clocking easier. So 37.5 times 4, that's going to be 150. Yeah, that easily exceeds the amount that we need there. Great. So it'd be nice if I could move this right here, but I can't because then it won't be touching this one here. So, okay, so then what this means now, and what I'd like to do is, I'm going to move this down one because I'm going to probably want to include some constant combinators here for lead followers. So already set that up just for us so that we know that we need them. And then what I'm going to do is I'm going to go ahead and add power all the way around this. So I'll line this up here, 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 and here. And that's going to allow us to easily run some cables. So editor abuc here, I've realized that the next section was like 30 minutes of me just talking about combinators, so I'm going to try to condense it down because most of it was math and trial and error and figuring different things out. So the goal of this was like, hey, I want these to only swing when needed. And the way that I did this was just relatively like looking at these machines here. I just said, okay, the first one was, if I look at the automation insertion limit here, that's 33. And every single time I'm going to pick something up, that's going to be 16 items I'm going to put in there. So I just simply said 33 minus 16, that's going to be 17 there. And that was just the condition. That way I'm never overshooting the insertion limit that's in there. So the second part was, and also just so you know, this insertion limit increases as you add more of these beacons, but it doesn't really matter. I'm just using that as a base number to base this off of so that it can always be running. In reality, what happens when you look at this here, if we go, let's say, one tick at a time forward, we can get to the point where this is 17. The moment that this becomes true and it's less than 16, you'll see that 1, 2 ticks later, this then becomes active. So that's it recognizing the condition, propagating the value, it accepting it, and it considering that it's active. So the moment that it's active, it's going to take about 10 ticks for it to swing across, and look that you can see this number is at 16. The moment that we go and swing, you're going to see, all right, well, it consumed a little bit more during that time, and now we're at 27. So even though we could accept over 33 items, or like basically 33 items in here, in practice, it's going to take, because it's going to take 10 ticks for this to swing, and during the time of 10 ticks, right, you know, this is going to consume 1/6 of 26, so you're going to be a little bit behind, so then the math basically turns out that it's going to be 6 behind, always. That's fine, but I don't really care, because this is anyway overproducing for this build the amount of copper cables, so I don't care as much. So anyway, that's just something just to kind of keep in mind, because that's just an easy way that I do it with the furnaces, is I just look at the insertion limit and I just subtract 16 from that and call it a day. Did the same thing for iron here. So 31 minus 16, that's 15. So when I started to mess with the copper cables, I started to get into like, oh, okay, well, I'll just do 100 minus the amount that I want to put in there. So that would be 68. So originally I set this up as, okay, whenever this is less than 68, I'm going to go and insert that. So let me go and copy that setting over, just so you can watch this. Well, the moment I started doing that, this started to swing twice. And I didn't really want that. I just wanted to swing just on an interval. And originally, when I had first done this, I just did the same rule, just, you know, minus 68. Or minus 32 to get me to 68 here. But then I started noticing this, like, micro stuttering that was happening. And the reason that it happens is a little bit more complicated to explain, but I'll try to quickly do it. So this has 175% productivity. Without productivity, every single time that you take a single basic plate and try to convert it into copper cables, you're going to get 2 back. So for every plate, you're going to get 2. So then that means with these inserters, when they swing into here, they're going to put 32 items in there, right? So without productivity, you get 64. And that's perfect because these down here are going to be able to pick up 64 every single time. So it'd be a perfect ratio. However, it's not at a perfect ratio because you have productivity involved. So that means that with 175% prod, you're actually going to get an additional 1.75 items per craft. That actually turns those 64 and it actually gives you 120 plates. So that's pretty massive. So what that means then, as I said, okay, well, I'll compensate for that, right? And I'm just going to go in here and I'm going to say, all right, let me take the max stack size that can be in here. That's 200. Subtract 120, and that gets me 80. So this worked and allowed this to just swing occasionally like this when needed. But it now started to swing for 2. And that actually makes sense just based on the amount that these are pulling out. It's close to 120. So they're going to swing like twice for every single time. This one has to swing once. So that all started to work out. So now basically this is swinging twice because these are constantly swinging. So every 4 times this thing swings, it has to just swing 1 time. And then I realized I overcomplicated everything. Because this is overproducing and it produces almost at twice the speed of this machine, all that I really have to do is I can just really simply go in here and just set this at 0. Whenever this gets to 0, it'll instantly craft all the items that I'm going to need in 32 swings and just compensate for it. And now these swing very consistently. Exactly when needed, and allow these to turn on and off and pulse on a very systematic rhythm. So I realized I overcomplicated it, made it way simpler now, and that's how this circuit works. So that is the inputs. So that's some of the things that I learned just kind of trying to get this to work correctly. But for the next section, the way that I worked this out was I just looked at these constant combinators here on what is going to be the input. So I wanted to very specifically control when the iron plates were going to be put in, and that's really simple. The max stack size here is going to be 100. So 100 minus 64 is 36. So that's just when it has to swing. And just kind of by nature, even though this copper cable can stack all the way up to 300 in here, it's not practically going to do that because in the actual final build, you're not going to be running a full green belt. So if I run this at like a full green belt's worth, you're going to see that like quickly over time, this is going to drain until the point where there's only 32 items coming out. So then at that point, what would happen was this was just flickering on and off constantly and just running as fast as possible. But you just couldn't actually get to the full stack size. And even if you slow this down, you're not going to get to that full stack size either. Even if you, let's run this at 16x speed just to fill everything up. If you ran this, you would see these like little micro like start and stops because this would never get to the full 300 because this would block, the output would be blocked first before it even would get to that. So the iron plates would easily get to that point of just basically always inserting up to almost the 100 limit that's there. But however, what you wound up seeing was I wanted this to always consistently swing at 16, and I wanted these to just swing when needed. So the way that I just did this is I just chose basically half the number of inserters having to pull things out, and I just subtracted 32 from 100, and I got 68 as the condition. And then that was just the monitor that I said. So instead of having them always active, just like if this output is full, then just don't basically insert copper cables until effectively this gets under that value. And that was fine. So that was basically what I did just to control these and then have these always swing at the exact same interval. And I wanted these to always make sure that they were picking up 16. So when you're seeing here right now, these are picking up 8 and 16. And the easy way that I solved that is I also said the exact same condition. So I said, and this is less than 68. So by doing this, you'll see now that these would consistently pick up 16 at a time. And that was the other's decision that I made, just to remove that extra little stop in between, because I knew that this would get up to 64 in practice. So anyway, after some trial and error, this is the final build. And then finally, the only other output that I did just to kind of turn on and off these inserters if needed and have these swing was just basically whenever this is greater than or equal to 64 inside here, then I want it to turn on and swing once. This doesn't do very much to help with this, but it helps a little bit so that effectively if it's under that value, then essentially it would not insert or swing until all of these can pick up exactly 16. So that was it, and that's green circuits. All right, so let's move on to red circuits. Previously, I was using a silo chest as a medium for this. So I used to use a silo chest, and I was surrounding then the silo chest with the red circuit module, so something like this. And actually, I could just literally show it here. This was the 240 per second item that I had created, and I just had straight up just copy and pasted it directly into my Purple Science build, and that's just what I used because it was a module, and I deemed that to be good enough. So this actually worked for the original build, but I want to get away from this, and I'd like to replace it now with a cargo wagon, so that's going to be a little bit of a design challenge. I'm also kind of debating using one or both of these, and the main reason is just because this is on a 5-tile grid, so if I have, these here, this is going to fit and hit maybe 3 of these, but I can't quite just make it so that it's 2, and then there's also symmetry issues, so hopefully I don't decide to go for the sake of symmetry and reduce UPS for that, but knowing myself, I sometimes will choose a less symmetrical build, or a more symmetrical build in favor of over a UPS gain. So knowing myself, that can probably happen. So I know this, and then I'm going to be just making with the basic oil processing because we found out in the chemical science build that this is more UPS efficient than having multiple fluids. And the game just has to calculate more things at the cost of just consuming more crude oil. But at my mining productivity, I don't really care. So we're going to try these different ones out. For research purposes, in my test environment, I've already set everything up to the max environment because that's what I have in my megabase. So your mileage may vary in terms of the research productivity. So I've already researched level 30 of plastic bars to get us up to 300% or 31. Same for rocket fuel, low density, and also steel. So steel was the most important one for this build, but now plastic is becoming really important. So for that reason, I can already I know that I can start getting away with the small chemical plants just because I have such an absurdly high research productivity rate, and then just connecting this one makes over 220 items per second. So this is not a problem at all for feeding all the plastic we're going to need. So this one small building here, this one overproduces greatly the amount that we're going to need. And this one still is almost close with just one beacon, and then with two, it'll easily hit over the amount that we're actually going to be needing to make for this build. So both of these are candidates that can work. Just again, annoyingly, this is on a 3 tile width, and this is 5 tile width, so I can't quite align it with just the cargo wagons. So let's start off with the very beginning. What I'm thinking about doing here is I'm going to start with I'm thinking that, like, ultimately I'm going to start with the thing that produces the most and then expand from there. So I know that easily, for the amount of copper wire that I have here, I can easily hit that with just one electromagnetic plant. I think in practice it's going to be really hard to fit all this stuff with all the beacons around, but I'm going to start with these 2 items and kind of work forward that way. So we're going to use this as our reference point. So I'm going to start with this. I know I'm going to use a cargo wagon like this to insert everything in and out of. So I know that let's try to just fit as many beacons around this as possible. So I'm going to start with that assumption, and we're just going to make this basically just touch here. And then what I can do is I can get a couple more beacons around here, 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 and then in like this. That's good. And then I could actually even fit one more and get this all the way up to 45. And that's kind of the nice thing about this cargo wagon being here, is that sacrifice a couple beacons, but you can easily fit everything in here. So, which is nice compared to the rocket silos before, because this whole entire right-hand side was completely blocked off. So you'd be limited to only 41 per second output. This can now easily exceed that and get up a little bit higher. So I move this out of the way for right now. We'll maybe keep an extra beacon, but I'll just keep this out of the way to give myself room to work around here. So I'm thinking right now, at least like the initial thought that I had when I was working through this was like, okay, I'm gonna probably have this to input into here. And then what I was thinking about when I was kind of originally kind of thinking through this design was I kind of wanted a place where I could easily fit this all the way around here. Now, what I can do to have both of these touching is I could have one more beacon in here, and that'll get me up to 45 and 43 respectively. But then I could have one more in here, and that would get me to 45 and 45. But I need now still a place to input the plastic into this. So I'm going to need here, the problem is then I am just slightly over the, I guess that doesn't really matter. We could have a plastic one. So let's say I'm going to start with this small one here, because that's kind of convenient, because I could easily just have this output into here. And then I could have this being the plastic one. So let's go ahead and mark a couple things that are going to be in here. So I'm going to need plastic. I'll have just 2 always for these. This is going to need an input of copper cables, so I'll do 2. And then this is also going to need green circuits. Now, since we're running them on a belt in the previous version, what I'm thinking is I'm actually going to have this kind of go around. So what I'm imagining here is like, I kind of want a place where the green circuits can go into here unhindered. So I could do that by wrapping around here and having a belt that forms. So let's go and do that. I could do this and then have inserters picking up off the belt. But, and I think that'd be fine. So that's a design choice. I'm going to kind of first lean into completely the concept of using this as a big, huge chest for everything. So then I can just come in here and I'm going to do this. So I'll limit this instead. So then that way, the nice part is all I need is just like one inserter for both of these sides. But technically the amount is slightly over the total. So if you see that, that's 33.3, 66.7, and then another 33. So that's like 112 or so items total. Or let's see if I did that right. So 33.3 plus 33.3 plus 66.7. It's 133 items. So yeah, I completely did the math wrong there. So for that reason, that's actually more than one inserter could have. So I could either put one more inserter in here like this to be able to insert everything that we're going to need and then just clock it. The other item is we could be bringing in green circuits from the side like this. And then another complete alternative option is I could be inserting the green circuits in here occasionally when needed. So we'll see what works out with the actual build, because this is going to get really tight in here in terms of the green circuits being inserted, right? And then I'm also going to have to keep in mind that I'm going to need an output somewhere for red circuits. So put this in here like this, right? And that we can do by doing some kind of cheeky things like this. And then kind of having this come in here and then this coming out. So that would be fine. And then we would just have to pass the green circuits up. That's an option. We can try this and kind of see what that looks like. And then an alternative design would be having this like that inside here. So then we could mess with both those. So I'll keep both of these as an option, and I'll just keep some room in here. But like, really, ideally, the ratio that we were talking about is we're going to need 333.3 per second. So that divided by, right now, the max speed of one of these machines here at 43.5, at least with the current layout. So 333.3 divided by, and this was 43.5. I'm going to need just over 8 of these. So that's kind of nice, because then we could just, copy this, move this over to the side, and kind of flip this around. So that already is looking like a module. That's pretty decent. I don't think I'm going to be able to easily fit this just as the center. We could do this, have the plastic on the sides, and then I'm gonna have to do some really weird shenanigans, and I can't really fit this in here as easily. So again, just this is what this actually looks like. I could do one plastic, I guess, but I need them to be on both sides. So this is gonna get kind of challenging. All right, I'm getting ahead of myself. What I'm gonna do is I'm gonna start with just this version here. So let's keep this as kind of a concept. Then what I'm gonna want, and ooh, this is kind of tough. I don't want so many belts in here, because I also want to directly insert from a furnace like this directly in here. So just kind of looking at this placement wise, I could easily fit at least a thing in here. So I'm actually going to, for room purposes, let's get rid of the green circuits, and I'm just going to assume that I'm going to have something coming in here so that I can insert the green wires or the green circuits into there. And then technically, I guess I could come to the side ever so slightly like this, and we could maybe wrap this around. That's not going to fit either. All right, I'll workshop that later. We'll figure out the spacing, but I'll just assume that it can kind of come in here somehow. So then what I'll do then here is I'm thinking like, I want something that is going to have the copper here. And this is only going to make 27, so let's just go and get this as much as possible. And then I got to keep in mind that this whole side's going to be mirrored, so let's just include that on the other side just so that I can kind of see that visually. And then I could place a beacon here. And I guess I could squeeze these together, because I'm not going to be able to fit enough beacons around here for me to get to the amount that I need, because I know I only need 88.15, and I could do that with just one electric furnace like this, and on both sides, and that would be enough, because that'd be over 100. I could potentially remove a additional furnace, which would be nice, but I'm not going to be able to directly insert it, so what I'm thinking is we do something like this, and we'll start with this. We'll mess with that. What I can do additionally here is, and I could technically go and say, I'm going to take this whole thing and move it over one. I'm thinking that because then I'm seeing already kind of a pattern here. I could easily bring green circuits in here like this and then come up like that. Which would be kind of nice because then I can bring this in here. Yeah, perfect. So that'll actually work out. The green circuits then can come in. So sometimes I like to just work with a mirrored version like this so I can kind of imagine where the flow is going to come in. So green circuits up here. And then what I can do then is I could say, okay, so how do I get more beacons to fit around this a little bit better? So I know I can already make this whole build. This is missing 2 for their tiles in width. So, and I can't quite fit another beacon around this and still be able to access these. So what I'm thinking I'm going to do is I'll actually move these directly under here. And then what I can do is I can move this up. And then I could move effectively the whole build. And I will copy this whole thing down here. Up 1. And that should be able to fit in theory. Thinking at least that it could. And is that not going to let me do that? Why? Can I not fit these? Oh, no, I can. It just didn't want to let me with the copy and pasting. The game doesn't like having these things under here like this. All right, cool. So that works. And then that's actually a little bit more compact and it fully fits them. Let's just figure out kind of how fast these furnaces then are. So I'll just put them in here. So 34 here, that's 68. That's well more than half of this. So that's fine. And just the 1 is not going to be quite enough because we're going to need 44 per second. I guess, can we, what happens if we fit another, oh, then these aren't touching. Let's see. What if I do this and completely surround it? But okay, we already know that this is going to cap out at 52. Is that enough though? Because, yeah, that should be fine to supply a half of this. Okay, cool. So we can just do 1 furnace in here. Great. And then just completely surround it. Awesome. That's a good thing. So that should be enough. Or, oh, no, shoot. 43. It's just ever so slightly off. 44. Oh, that's frustrating. It'd be so convenient if I could get 1 more beacon to touch this. Just 1 more. Ugh. Yeah, I don't think I'm gonna be able to fit this in here. That's already the max range, and if I get this doesn't buy me anything. I really need like 1 more tile over here, and that would be fine. Ugh. Yeah, that's unfortunately not gonna work. And I know that I need, like, again, I can't remove these beacons here. Because now this is going to be at 41 per second, and 41 times 8 is going to be 328, and that's below the amount that we need here at 333, so shoot. And then also, yeah, I need, because I was thinking about, like, I would just have it 1 cargo wagon for everything. So for both of these sides, and that's not going to work either. So let's undo this. I'm going to unfortunately need 2 of these, and I will just deal with it. So this should be enough, and we could place this around here like this, and then pretty easily just have a pipe connecting all these. Now, let's go back. Let's see if I can fit this in here instead, and again, just 1 tile off. If this was 6 wide, this would be easy. I think all I'll do is I'll just imagine having these 2 in here, and then I'm just going to need an input here for the coal. So just imagine that. And that's fine. These will be way overkill and will just run occasionally, but that's more than enough to fit both of these. And then we can do otherwise. I'm also going to remember that I'm going to need up here an input for copper. And I will use this as a filter. And I'm also going to need now 1 down here. And then that's not too bad because I could easily fit this in here. And that's actually kind of convenient because, like this build down here, I'm kind of wanting this to flow all the way through the whole system. So if I place this in here, That'll be enough to get the copper in there. And then what I can do afterwards is I could bring this up like this. And then later on, we're going to be needing, and I'll go back to over here. We're going to be needing to craft an assembly machine, some iron sticks. So we're going to need one more place that's going to make iron plates. So what I'm thinking then what I'll do is kind of going back over here on the output finally, and this is probably getting a little bit ahead of myself, but I'm just going to do it anyway. So we'll put this in here, and I'm going to filter this so that it only takes, and let's just grab this because it's easy to reference it. I'm just going to filter out the copper. That way, in this build, this can go down to eventually where the purple science head is going to be, or the tail module, and then that can just come out as an output. So that's kind of good. Okay. So next here, can I get this to come all the way across? Nope, not gonna be able to do that. So we'll figure out the output here later. I'll just roughly and crudely put this in here. And I'll figure out kind of where I want that to go later. No, let's just do it now. So what we could do is we could have these come down and come in here. And then again, just have these outputted right there. And then right there. And what I'm going to do is something that I mentioned in the last video. I'm going to have them always not blocked. So just by preference. So I'm always going to side load these. And we'll do the same thing down here. And I will place this just somewhere. This is fine. This is enough to get around this now. And then this can easily just place right there. That could work. I guess. Yeah, that's fine. So, or, oh no, but this is now, ooh, that's going to block it. I don't like that. So I can move this around. Oh, I could fit this perfectly in here. And then, okay, what I could do is move this one down and this one over. Great. All right, so then this is always going to be in the outside lane. So that's then convenient because then I can bring this over here. And then as this comes up, which is I think where I want this to go. Yeah. Up and out. So move this over here. Now this will always be on the outside lane. Is that where I want this to be? Yeah, because this is, and then I guess I could do this following maneuver here. And then this will be then now on the inside lane here. Or you know what? I can avoid all this altogether by just doing this. Now this is always on the inside, guaranteed, and this will always put it on the outside. Great, perfect. So then this will go somewhere, and I'll just make this an output. Cool. I'll do that. Just so that later on I can watch it. So I've got now the copper inputs. This is all fed. This is fine. This is fed. So now I need the green circuits. Well, that one's pretty easy. I will just emulate that in here. I'll bring this down. And then I'm going to grab some constant combinators just to mark everything. And then this is going to be green circuits. I'll just assume 240, even though I don't think we quite need that amount. Because I know that like half of this is going to be 242, so just 121. So it's going to be slightly more than that, so we will need a little bit extra to come through here. But that's okay. So I'll just right now model it this way. So then next what I'm thinking is, okay, we've got the green circuits in, great. We just need plastic. Well, plastic's pretty straightforward. That is going to be just, let's see, this is the red circuits coming in. Can I bridge this gap here completely? Nah, it's just off at one. All right, that's fine. We'll keep this in the middle. So then let's say I have coal somewhere and I don't really care where that comes from. I just need coal at some point. So let's just create an input for this, and then conveniently this can kind of come in here. But you know, I could even do belt weaving because it doesn't need to be as fast. So that's kind of nice, and sorry for those that don't like belt weaving, but this works. And then for this, I can just have some underground pipes or even go around the outside, and that will be just fine. So we'll just do this and we'll pretend we have somewhere a petroleum setup. We can even do this here. Okay. So then here, move this down 1 just so I can have an input, and I will say coal. And then that can come in here, and then these can just directly insert into there. That should be fine. So that's all good, and I'll just simulate right now, and I don't know exactly where the fluid's going to come from, but I'll just simulate right now petroleum in here. And I'm just going to watch this so that everything is fully stacking up. And okay, it needs an output. Nice. And I think this blue belt is going to work anyway, because when I originally designed the inputs, I already am doing some weird weaving here of blue belts, because I know that we're not going to need that much plastic or coal that's coming in. So this should be fine to kind of keep that mantra. So this works. And then let's just monitor all these outputs here. See, this is all working. So one thing that's going to be kind of tricky with this now is, how do we do the wiring up of the circuits? So I think that's pretty easy because both sides should be exactly identical. So what I can do is I can grab a constant combinator in here, and I already have selected in my hotbar for convenience. Fantastic. So what I'm going to kind of want to monitor here, and this is going to kind of share things. So this is kind of tough. I got 3 inputs, right? And I don't have like 3 discrete inserters that are putting things in, and the ratios are a little bit different, right? So this is going to need here, it has a max stack size of 40, and this has a max stack size of 40. So, and then this one's going to need more. This is going to need 80 per second. So I could just have a dedicated one for copper wire. So let's just go look at that. And that seems fine. And then the other one can make up the plastic and the green circuits that we need. And that could easily handle that switch between those recipes. So I could already just go ahead and pre-mark that. So this one's going to just be plastic. And, sorry, we'll go do green circuits. And the same thing over there. Cool. So then what I think I'm going to do, and let's just grab already some power poles so I can start sending signals across this whole thing. So I'm going to add one somewhere over here. And then one... oh, I need this to be legendary so I can go a little bit further over. Great. And then I could do this easily. And then what I can do then is, let's just get power pretty much everywhere. So I'll just get this all the way to the corners. Why not? And then, yeah, this is fine. And then, do I need this? No. And if you, by the way, if you shift left click, you can remove all the wires that are connected to the power poles to make your life a little bit easier. So you can connect them up like this now and manually wire up all the wires if you tend to have a little bit of a preference to have in the map view all the wires all be consistent like this. So, and it's not consistent because this needs to come down a little bit more like this. Perfect. And then I can bring that over. Nice. So now all the wires are, or at least the power is distributed everywhere in the build, so that's good. And then what I could do next is, okay, let's monitor the input of, this one's going to be the lead because it's on the bottom, so that's fine. So then I'm going to monitor this, and I'm going to say whenever the copper here is less than, I don't know, so the automated insertion limit is 80, so we'll say is less than 80. And then I'm going to do minus 16. I'm going to output a check mark here. Cool. And I'm going to connect that up here. And I'm going to say here, whenever this one is greater than 0, this one's greater than 0, then it should swing. And I could also just do this so that now, whenever on demand, I want these two to swing as well. So I can copy this and do the same output there. So that seems to be in a good spot, because now these should overall eventually all sync up here for what they're outputting. So that seems to be good, and this is constantly running here, right? Yeah, good. So the next thing then is I need something that's going to control these. So, and I can actually just bridge this connection pretty easily because I could go down here, bring this wire down here into this, and I can't connect that. All right, move this over here, connect this wire in here, and then I can easily just put this back in there. Perfect. And then I can copy, again, these rules, and then bring, this strange shenanigan stuff is crazy. I love it. And then we can bring this over here. Cool, that's good enough. Is that going to bother me that the wire's on the wrong side? It is. Oh well, alright, it looks slightly better wiring-wise. Alright, so there's copper, all connected together. This one down here seems to be running just enough, and this seems to be always constantly in a working state, so alright, good enough for me. Alrighty. So then, the next thing that I'm going to want then is, let's grab the plastic monitors. So, this is plastic input here. And this is a plastic input here. So let's connect this up. So I'm going to need something that can monitor this guy here. So I don't know, I'll place this somewhere that I've got space. Where can I find space for this that isn't... I've already limited myself. Alright, this is fine. I will connect this in here. And then we will say in here, whenever the plastic is, and the insertion limit is 40, so whenever this is less than 40 minus 16, I want to emit, again, a check mark. Make that one green. So we'll run this as a green wire, that way if I need to run in more places, we can do that. I can put this in here, put this in here, and let's just see what happens if I just do it without monitoring the green circuits. Oh, that's, yeah, that's bad. Oh, wait, greater than 0. Seems to be fine. Alright, that's kind of cool. That's kind of potentially not that great, but I could add one more and say this is less than, and the insertion limit should be the same as 40, but I could just have it as like a safety net. I could just say 16, just as like a, just in case it goes too far under, but this one should always lead it because they have the same insertion size, so that should be fine. Okay, and because this is 2 to 1, whenever this one swings, this should be swinging. I wonder if I can just get away with just one like this. That'd be kind of cool. And I will say again, check is greater than 0. I guess this works in the sense that always plastic is coming out first. If I don't know if this would make any difference in priority. Don't think it does, but we'll see if this is stable. If not, I'll have to add some more wires, so hopefully I don't have to. But that seems to be working just fine, and I'm not seeing any issues with output here. That's good. So what happens if I block this off just to monitor this? So this has no plastic, and it just has the green circuits. So that condition that I had there should prevent this from ever having an issue. Cool, so it's constantly running. All right, great. That's just one signal I need to run. Great. So then I can copy this setting here. I can copy these settings down here. And then I could run this green wire down into here, here, and here. And just monitor that that's constantly working. Great. All right, cool. Really straightforward. We got all those clocked and everything connected. And then now I just need to do the red circuit, so that's pretty easy. And also like the furnaces here, and also this coal, but that's not too bad. So then what we can do is let's add more constant combinators. So again, continuing on with this process, we're going to read this. Let's actually go all the way to the very top one, the one that we're monitoring, so that there's never an issue with it. And I'm going to read the contents. I'm going to, yeah, just the contents is fine. And let's calculate what this could get to. So if the plastic output here is 40 and we can craft, it takes 2 to make a single advanced circuit, that means it can stack up to 20. That's fine, so we can easily just make this condition then 16 in here. This is greater than or equal to 16. Again, I'm going to output a check mark. And this one I'm going to run on these power poles. So I'll do this here, and then again grab a check mark in here. Greater than 0, perfect. And then let's bring this all the way down here. Fantastic. And there, perfect. No, 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 no. What have I done? All right, that's good. And then we'll bring this in here, and then again apply the setting by shift left click, and then come up here and finally connect this in here, shift left click. Item ingredient shortage. For a brief moment, we had a flash there, but it seems like after everything has synchronized, this is fine. Great. Oh boy, I need also green circuits. Because it's pulling off a belt. Let's just hope this works. Let's do check greater than 0. And that makes sense that this is running every 2 cycles compared to 1 here, because this is a 2-to-1 ratio on those. So that makes sense. That's good. Man, I'm really liking this build. This is good. This is in a pretty good spot. So then I want to clock these, just that they're not flickering every single time. So let's grab an output for this, and conveniently we can kind of just place this in here. It does not matter, but since we're using this one as the lead, I'm going to face that direction always. Then I'm going to read the contents, and this has a maximum size of 41, so this is less than 41 minus 16. Output, check, great. And then we're going to just connect these 2 up, and we're just going to say check is greater than 0. So this is getting stuck quite a bit, so one of the things, and this is just a voiceover on this because I do some math wrong here, but basically like every coal that you're going to put in, you're going to wind up having 2 plastic bars that come out, plus an additional 3 because it's 300% productivity. So you're going to get 5 plastic per coal. So the math that you see here is just wildly wrong. Somehow I assumed it was 8. So anyway, the point is like the decider combinator logic that I'm going to set up here winds up being, okay, I'm just going to set it to like 4, for example. So that is just, and then that 4 would turn into like 20, which is perfectly fine to exceed the amount that it's going to need per swing. So, and in this case, I just did less than 64, and it should just run and cycle on and off. As long as you're under those ratios, that's completely fine, and then we're in a good spot. You could probably even go, this is all the way down to 0, because this will already create the maximum amount that we have. There we go. That seems to be cycling just fine. I just chose 64 arbitrarily. I just divided this by 2 and just assumed. To be fair, this is probably fine. This has to run so very infrequently. So finally, the last thing that I do here is I'm going to add a clock for the furnaces. I'm not going to show that here, but I just want to address that I do it. It's exactly the same thing that we already did for green circuits in this video, so it's nothing complicated or fancy here. Okay, so now we have a build that is constantly making red circuits, which is wonderful. However, I don't need it going up. I need it to go down because that's where these are. So let me workshop that here for a second. All right, so after messing around, I finally figured out a good combination to mess around with this to get it so that it's never blocking each other, so they can always just constantly freeform output here. So what I've settled on here is now these are always going to output on the outside lane, and then that's going to join in here to be on the inside, and then this is going to be in the outside lane, and then they're both going to join here, and then effectively the spacing will just be that eventually these will all connect and then go downstream. I'm not expecting this to be 240 like we said before. This should be making 174 and then times 2. That's 348, which is more than 333 that we need, so that's perfect. So now that we have this all circuited up and connected, the next bit that I kind of need to figure out is copying this and coming up with some kind of a solution where I can fit an oil refiner in here. So see if luck will have it and I can just nicely nest this here kind of in the middle. Ooh, that is... Oh, that is so close to being perfect. Like I can smell it being connected. There's gotta be some way to reorientate this. Let's move this over here. Let's see if I can do this by removing this, placing this here, and moving these two in here, right? Then let's move this around and remove all the petroleum. Let's see if we can fit this in. So that gives me enough room to connect this in here like this. And it's not gonna be symmetrical, but I don't care. This is good enough for just the one building being wrong. So then we could come in here like this. Oh, this might actually work out just perfect. So let's remove... Yeah, and then I can remove all these because I'll keep them as separate sides. That's okay with the circuit conditions, because like running all these across and all the extra wires would need some kind of complicated shenanigans going on. I don't quite have enough to independently do greens and reds. We'll see if we can, because I'll see if I can do it, but I'm going to leave it as is for right now. So, but that being said, let's move this over here, move that there, move this over here, 1, 2, and then we can even cap these off, and I'm just going to use a turbo belt just because I very rarely make blues on novice, so I'll deal with it later. Why not? I can increase production on novice to make some blue belts, that's okay. So then this is good. What that would allow us then to do is to easily rotate these, place these in here. That's not bad. Here, and then here. Nice. And then these can come down. Perfect. Oh, okay. No, that doesn't work because I don't get the... Oh, wait. Oh, this might just work out. Ladies and gentlemen, we may have a solution. Let's see. So I know this is going to kind of look weird, but what I could do is, let's say I move these down, and then this is all perfect here, connected. What I would need then is just an output for petroleum, so let's just assume this, place this in here, cool. And then can I get this to get around this? Oh, just almost completely perfectly. So let's see if I mess around with these power poles, because I don't need quite this many anymore. Let me see if I can place this in a slightly more advantageous location for me. Because if I can do this, then I can easily get this out. And then that could be just the crude oil input there. It's kind of what I want. And the other thing is, do I need plastic to be on both sides? Technically no, and I'm really careful about which side I put it in. No, that's not gonna work either. That's some funny shenanigans. Okay. Oh boy, I'm hating all these power wires and where these things are. So this worked out nicely, this connected nicely in here, and I liked this. And then I just need a power pole, so say I just put these down here. Is that enough? If I just say, yeah, that'll work. Just place them down. Just shift everything over. Perfect. Yeah, this is crazy with all the circuits, but why not? And then this is making 717. That should be plenty to power all this stuff here because we have such high productivity rate. Let's just try it out. Just find out if this beautiful little contraption here in the middle winds up solving our problem. The only thing I don't like about this so far is I don't have an easy place for me to output. I like to be able to turn this on and off and cycle it just when there's enough in the system. So I wonder if I could just simply put, and I could actually use now these as the center line here. I could run this wire up here that red wire goes across. Oh, that connects all that stuff. So let me make this a green wire instead. And that's actually probably why I keep that rule of like alternating between greens and reds for inputs versus outputs. Because now these two sides could be synchronized pretty easily. And then these are all red wires coming in here, so I could remove this already here and then just connect this directly. And then here, so now all the red circuits would all be synchronized. So that's good. So these should then eventually all synchronize on the left-hand side. Let's see if we can remove more and more combinators. That's better. Oh, what I could do is this then. Okay, so let's say I put this in here, bring this up, and then, oh, perfect. Okay. The reason why I want to do this, and I'll explain that, is I just want a storage tank. Some way to monitor the fluid in the system. And I could even move this over one like this. Oh, I can't. This is in the way here. Oh, this is fine. This is fine. You just connect it right there. Perfect. And then we'll move this over here, and that's good enough. So the reason I'm so excited about having this storage tank here is because now I can monitor it with the circuit network. And what's convenient about that is if I connect and add a decider combinator here, I can now connect this, and I want to be able to actually physically turn this off. If I press F5 here and look at the active states, this will continue to run indefinitely and will never shut off, even though the fluid in this tank is going to consistently go up and up and up and up. And eventually we'll get to the point where it will just slightly be higher than it actually needs to be. And you can see that as this is going now over 4,000, it's going to slowly rise and get over 4,100, etc. So really, I don't need it. It's running just slightly too fast for the total production that we need here. So what we can do here then is I can connect a red wire, and I'll wind up just simply saying whenever the petroleum gas is less than 5,000, I want to emit a check mark. And this is simple enough. So now it's going to take a little bit for us to climb up to that value again, but short cycling this and basically allowing it to fully disable. And we could set this even to whatever number we want. We can make this 2,000, for example, here. It doesn't really matter. Just how much of a buffer we want to hold. But now you can see that this will now be able to actually physically turn off, and you'll see that little red. So that's actually kind of a nice thing, is being able to fully deactivate it and shut it off. That's a nice little just UPS optimization you can make. So that's kind of why I wanted it up here. So, and then the only other thing just to always monitor is just how much petroleum gas you actually have in the system. And so you can see here, this is too low for this. So I'm going to increase this so that this gets up to, let's say, 5,000. And that should be enough to have enough petroleum gas in here, because we're going to try to get this so that there's enough pressure in the fluid network for this to happen. So we can easily just do this real quick and just let this run for a little bit, just to basically increase the amount of petroleum gas that's in here. So let's say this is less than, I don't know, 10,000. We can just let it just run for a while until it gets to that point. And then we can connect the network back up again. So now these should be constantly always full. So there should be enough pressure in the system to constantly feed these. And so then this will actually be able to then turn on and off, just cycling around it, and have a better UPS optimization for that. Cool, so that's it. So the only other thing that I'd like to do, just looking at this, is I'd like for this to be further down, which actually we could do pretty easily here just by moving this over. And then this can just output like this, and we'll do the same thing on the other side. I'm gonna grab that and out. And great! Alright, so that looks like a good module for red science. Alright, I've gone ahead and connected the green circuit up to this, and this is completely fine now, perfect. And this is why I wanted to kind of have this pass through here, because I wanted this to perfectly be in line here, and then finally just have the iron outputs. That's been kind of the plan all along. I might move this around because I can't really fit it in here, but I'd like it kind of maybe not right in the middle, but I think this will be fine. If I could actually get it to the point where maybe it's down here, this might be a good spot for it, but I don't know if I have enough room for it, but we'll try it out. We'll see what we can do in order to make this a little bit better. Actually, now that I'm thinking about it, might as well just do this, because Could easily just connect this in here like this. And then I could just run this all the way across, bring this down. Oh yeah, that's a way better spot for this thing. Nice. It even looks like it's supposed to be there. Doesn't touch that, ideal. And then can I get this all the way down? Oh, almost. Oh, it's good enough, perfect. And then I can connect this, perfect. Then that's got a little nice little spot and I can remove this altogether, yay. All right, so now we have a full module that's going to make red circuits and green circuits, and that's perfect. So, and this is already kind of lined up so that we can also just take the excess and start using it for productivity modules. So what do we have left to do? Well, that's the productivity modules. That's going to be super straightforward and easy, so we'll do that first in the next video. And then I'm going to go and create the materials that are going to craft these three things here and make ultimately the production science packs. And then once that build is done, I'll compare it against the original build that I've created, and we'll do some UPS benchmarks. And then finally, and this is probably going to take me a while, I'm going to put it actually in my base itself and use all the new wonderful voiders that we have here. So this new voiding setup. So stay tuned, subscribe if you're interested in seeing that and the conclusion of Purple Science. So as always, thank you so much for watching. My name is abucnasty, and have a fantastic day.